All right, questions? Yeah.
4.21.
Thank you. 4.21. Yeah.
When's our test coming up?
We'll decide on a date, probably the beginning of next week. You'll vote on it.
Okay.
I didn't say that. Didn't I say that at the beginning? You check, you vote for yourself or not? I let you pick it. So, how about this? Why don't we just set, how about this Monday coming up? Whoever's here gets to vote on the day you want your exam. Fair enough? And this is a diverse crowd, so some people want it one day, some the next. So, the majority wins. There's nothing I can do to make it right for everybody. So, just come and think about, look at your schedules, think about when you want it. And remember, it's comprehensive, and as you know, everything builds, right? So probably it would be smart to have it at the end of the section on, really, yeah, it'd be good to have it at the end of the section on steady state behavior that we're doing now. Sometime in about another, maybe not next week, but the following week. So think about that date, okay? 4.2. This is a brand new marker, but I can't promise you it's going to work the way it's supposed to. Man, they don't make them like they used to. This is a brand new marker, all right? I mean, at least it's right out of the box. This one's a little better. So for problem 4.21, they have a 4 amp source. One ohm and minus J1 ohm. And J1. And they want this voltage. Do you agree with me? You asked, right?
Yeah.
All right, how are you going to do this? By the way, there isn't one way. All right, I wanted you to just think about it in a reasonable way. Pretend this is all a bunch of resistors. If I wanted the voltage here, couldn't I use current division to find the current here? How many see that? I got current going into a parallel combination to it. How many see that? Right? I could find the current here. Once I had the current in this section, I can multiply it by the impedance, the complex resistance, to find the voltage. You all see that? Another way that produces the same results, couldn't I make an effective resistance or effective impedance of these two because they're in parallel? How many see that? And I could just multiply by the current, right? Now the current's going down. So really, you could say, well, the current going up would be minus 4, but don't ever let that bother you, okay, class? That's simply, it has to do with the relative plus to minus convention used. Current's going down this way, it's 4 amps. So technically it's minus 4 going up. But how do you want to do it? You want to use current division? All right, so here's what I'm going to do to make it easier on everybody. He asked, now, do you all agree we can find a parallel combination of those two? Right? And then you can multiply that by the current, which is 4. So I'm going to do this. I'm going to say this current going up is just minus 4 amps, just to make it a little, because you like current going up, right? So it's minus 4 amps going up. Now what I'm going to do is figure out the current going here using current division first. And I'll just call that I1. And I know I1 there would be the total current minus 4 times the opposite impedance, 1 minus J1, over the sum of the impedances, which is 1 minus J1 plus J1, right? Or what is that going to be? Well, if you take a look at this, this is minus 4 times 1 minus J1, right? Over 1, right? Because the minus J and plus J is canceled. Do you all see that, class? Can you see it in the back there? Okay. And that 1 doesn't matter, so I have minus 4 plus J1 amps flowing if I leave it in terms of what?
With 4, there's not minus 4.
I mean, there's a 4 here too, yeah. My bad. Thank you so much. You're right. Okay. Do you agree with that, everyone? Now that's in rectangular form, not usually done that way. Usually it's a magnitude and angle, but I'm going to leave it there for now, right? Now that's the current flowing this way, and if I wanted this voltage, it would be that current, right? It would be I1 times J1. Do you all agree with that? How many see that? It's the impedance, just like if it was a resistance, right? If you got the current and you want a voltage across the resistor, you multiply the current that's flowing through the resistor by the actual value to get the voltage. Y'all see that, class? This is an important class today because there's things here I'm going to address that probably are confusing. People that cram will probably get really hurt on the next quiz. So, if you take a look at this, this is equal to I1 minus 4 plus J4 times J1. I'm going to do it this way one time. This would be the voltage. Now take a look at this. I have J1 times minus 4. That's minus 4J, right? And then the next part I have J times J, which is, yeah, J squared, which is minus 1, isn't it, class? Remember, the definition of J is what? Square root of minus 1, isn't it, class? Right? And some people will put plus or minus square root because technically that is true. Anyway, so I have J times J is minus 1, and that's going to be minus 4. So here I really have what? Minus 4 times the quantity 1 plus J. I'm just showing you ways of writing this. Do you agree with that? Another way to write that is what? Minus 4. How can I write 1 plus J? Well, isn't 1 plus J have a magnitude of simply square root of 2? How many understand that? Right? Whenever I see people not understanding this, it concerns me. So I'm going to take a second. If I have 1 plus J, that's rectangular, right? Graphically, what is it? On the real axis, it's 1, and on the imaginary axis, it's 1, and therefore, this is square root of 2 at 45 degrees, isn't it, class? Y'all see that? So I can put this here, the 1 plus J is just equal to the square root of 2 at an angle of 45 degrees. Do you agree with that? How many do? Another thing I want to show you, because people, what I'm really trying to do here is answer a lot of things, questions that I think people have, or try to clarify things that people don't understand. Now, if I look on the axis of complex plane, where this would be the real numbers, and these would be the imaginary, and the vertical axis, all right? Just listen. If I have the number 1, it would be graphed here. That's just 1 at an angle of 0 degrees. Do y'all see that? If I had J1, it would be graphed here. It's just the length of 1 from the origin to that point. It's on the vertical axis. which happens to be the imaginary or j-axis. J could be represented as 1 at an angle of 90 degrees. Do you agree with that? Now, if I come over here, I could say this is minus 1, right? I mean, that's just, real x is just minus 1. Or you could say this is equal to 1 at an angle of 180 degrees, couldn't you? Or plus or minus 180. Y'all see that, class? So what you can do with this minus 4, now this is how it's usually done in polar. I'm not going to leave that as minus 4. I'm going to leave that as 4 at an angle of 180 degrees. Do y'all follow me? And it could be positive or negative. So I'll take that minus 4 and just make it 4 at an angle here of 180 degrees. And now you can see one thing I can do. I can add this and this, right? So this could be 4 square root of 2 in magnitude. It would be at an angle of, well, 180 plus 45 is really what? 225, right? Isn't it, class? Now that's a number, but this is a way to do it. That's one way. I hope I'm answering your question. Another way would be getting a equivalent impedance of these two. Do you agree with that? They're in parallel, correct, class? You have two in parallel. This is one impedance, this is another, right? I know they're series, but I mean the value is 1 minus J1 here. You could find that and simply multiply it by the current to find the voltage. Do you agree with that, class? Let me see your hands if you do, because I gotta make sure you do. Does anybody not see that? It should be clear, but if it's not, I'll try to make it clear. All right, so let me erase this. I'm going to do this. I'll put it back the way it was originally shown. I'll put here and just 4 amps going down. So my goal here is to find an equivalent of these impedances. And what I want to do is go ahead. I'm going to still have 4 amps down, but now I want one equation for the impedance in here so I can get this voltage. So do you remember how to get this? Well, if I'm talking about in general impedances, if we're talking about two impedances in parallel, Z1, 2, one way to do it is 1 over Z1 plus 1 over Z2. Correct, class? That's one way. That would be just like resistances, right? And if there was more than 2, you would have 1 over J3 added, and 1 over one over Z3 and 1 over Z4. Or, and just so you can see this, if I go ahead and I take Z1 times Z2 and I multiply the numerator and the denominator, then I say that this is equal to Z1, Z2 over Z1 plus Z2. Everybody follow me on that, class? Either one is acceptable. I'm going to go ahead and say this equivalent impedance here is going to be Z1, it's this. All right, times J1 over this plus this. Do you see how when I add them together, the minus J1 and plus J1 cancel and I'm left with just 1? So I can say that Z12 here is going to be, I have J times J is minus 1 with a minus sign is 1. And then I have 1 times J is J. You all see how that is the impedance? How many do? Okay, good. In the back, can you see it far back? All right, that would be the impedance, 1 plus J1. They would be in series. If you wanted to draw it, you would put a resistor here of 1 and an inductor here with an impedance of J1. That's the equivalent of all that. Now if I wanted this, I'm going to stop for a second. Y'all see what I'm doing here, class? So if I wanted this voltage, I'm going to erase this now. If I want this voltage, I could first get the plus to minus voltage by taking 4 times this. Do y'all see that, class? And then I could just say, well, the negative of that is the actual voltage they want. Do y'all follow me? So, or I could put minus 4 there, right? Matter of fact, that might be quicker. So if I just made this minus 4 amps, then I could say V naught is minus 4 times 1 plus J. And that's in fact what we got last time, isn't it? How many see this class? All right, any questions? And that's, yes. Did you have a question or? Yeah.
I do. I was wondering why it's not J1 minus J squared.
Yeah, that's what.
Well, what is J times J? This brings up a question I'm going to have to probably answer several. What is J times J? Isn't that minus 1?
J times J? J squared.
What is isn't J defined as the square root of minus 1?
Right. Okay.
Square root of minus 1 times square root of minus 1 is minus 1. Yes?
Thank you.
I got a bit of a question on you wrote this 4 ways on the problem, or on the example that you raised. Which way would you want us to write it on the quiz?
I will ask for answers normally in polar. So it'll be magnitude and angle.
Okay.
Magnitude is strict positive, angle is something that you would find.
Sounds good.
Now I want to tell you one thing. Your calculators are your best friends here. They do all this stuff. They go from real and imaginary to polar that fast. The 83s, the 84s, these are all TI. 89, what is it, 93, the Inspire, and I mean all these calculators that are engineering based have been designed to do this for you. What is yours?
TI 36, and it does.
Oh gosh, 36. I'm not sure about 36s because is that late? Did that come recently?
Yeah, I mean it does these.
Then it probably does them even better.
Because I got the answer. Well, I guess because you said the magnitude is always positive, so it changed it. Okay.
I think I have the same question, but I don't know the answer. Because on the solutions, it's negative 5.66 because that's like 4 times the square root of 2.
You can leave the negative in front of it, and that's what he did. He put an angle in there.
Yes, he didn't change it from the angle of 45.
All right, he left 45, but there's a negative sign.
Yes.
That's fine.
Okay.
They're
So
the,
it's
they're all
negative
the, they
on
mean
quiz.
they're all the same.
Okay.
However, usually I would prefer just a magnitude and an angle. The negative sign should be 1 at an angle of minus 1, or 1 at an angle of 180 degrees. Pardon me.
So adding 180 degrees.
Yeah,
to
but you don't
45.
you don't have to write it. Just,
Okay.
I want you to follow the basics. Okay.
Thank you.
Another question? Yes. Anybody? Yes.
I have a question about something else. What's the difference between like equivalent impedance versus equivalent admittance?
I don't even dabble with admittance in this class. Let me explain this. Please listen. Admittance is 1 over the impedance. So, if you look online and in your book that you bought, if you bought it, you're going to find admittance. Now, the reason admittances are mentioned is because for some calculations, it's a lot easier to use admittances. But in a nutshell, it's this. The admittance symbol is Y,
Yes, sir.
and it's simply equal to 1 over Z. So, if you had Z equals 2 ohms, the admittance would be 1 over 2 or 1/2. And admittance is in Siemens per meter, but I do not ask about admittance here. The other classes I don't. You got enough to worry about. the last thing you need to do is be pulling your hair out about these things. That's the way I feel about it. Alright, question about any of the homework before we move on. Most of the stuff you need to do is expose yourself to how to do it, and your calculator's your best friends. Yes?
How do we like do that in the calculator?
What's that?
You know, change it to polar or?
Depends on the type. This is the one thing. I'll just say this right now. You're going to be getting matrix equations where you have each matrix entry is not strict real, it's real and imaginary. And you're going to have to do things where you're going to solve a 2x2 matrix solution. You're going to have two equations with two unknowns, but the coefficients are complex, and you're going to have to solve for like the i's or the v's, all right? So you have to learn about your calculator. Now, if you have a 36 versus a TI-84 versus something else versus my old HP, all of them are different. There is no one way, and that's the bad thing. So, which kind do you have, sir?
This is a 83.
A what?
83.
83 is a good standard. That's online. As a matter of fact, do me a favor, guys. You have your, what is it, GroupMe or Facebook page? GroupMe, right? Guys, I'm sure there's people here with 84s, 83s, 89s, 93, 36s, Inspire, whatever. Just put on there, when you figure it out for everybody's benefit with that calculator, how to do it. And usually they give links. Yes, miss?
So when I took this class before, they recommended the TI-36X Pro.
Great.
Because that one, you can actually put it in the polar and in the other form, and the calculator will figure it all out for you.
That's fine. But I'm going to say all the I've taught this for a long time. I mean, I taught it before, God, I taught it with an Anyway, you can do it with an 83. You can do it with an 84. You can do it with all. The only thing there's a learning, takes a little time to learn. You get online, you'll see how to do it. I promise. The calculators that you guys got, the 36s, it's probably a breeze, but you do have to spend time learning how. And don't do it the day before or the night before the quiz, because there may be things that you don't understand, don't know who to ask. Do it before. And by the way, the reason I try to encourage you guys to get on GroupMe and watch the lectures online is for one real reason. Somebody here is going to figure it out, and they can tell everybody. You can help each other a lot here. I mean that, and it's beneficial.
I'm not sure if you said this already, but is it okay to have like a negative angle?
Yeah, you can have, when you have -1, that's actually 1 at an angle of plus or minus 180 degrees.
Yes, so it's okay to actually have it on the.
Yeah, it can be plus or minus. Usually the angle has only one value.
Yeah.
But to be frank, I'm just going to say this. Any angle you have is defined between 0 and 360 degrees. Do y'all agree with that? Now, if you add another 360 degrees, you come back to the same point, because you're literally winding the hand of the clock all the way back to the same point it started. So you can add or subtract 360 degrees from any angle, and that is still an angle. It's unique. It's just most of the time they want the angles limited to between -180 and +180. Usually, I don't force that. I'm just telling you that's the way it's done. And if you got, how many are MEs in here or Arrow? You guys get that kind of stuff from your instructors like Birch and stuff? He does not want to see 720 degrees as an angle. It'll drive him nuts. He wants to see something in the range of plus to minus 180 degrees. All right. You got other questions about the problems? Because now what I want to do is tell you this. This is not difficult stuff once you appreciate the fact we're just dealing with resistances that have complex numbers associated with it. That's it. All the same techniques that you learned before are applied here. As a matter of fact, the best way to do this is show some. So I'm going to go ahead and do equation or do problem 430, and then I'm going to do a note. But I want you to see how nothing's changed except now there's complex numbers. And by the way, you're here today on a Wednesday. I'd say these are probably serious students. If you're down at the Gulf of Mexico, fishing or whatever, you probably need to have a good hard look at yourself in the mirror and ask yourself, what in the world am I doing? But you're here and I'm glad you're serious. So this is equation, or this is problem 430. And I do appreciate serious students. And this is sort of a reverse order problem. This is a typical kind of engineering problem, where they got something and now you gotta figure out something, but it's not in the standard order. All right, so follow me on this. He wants I2, I1, and Vs. But he gives you the output voltage. Now, you've got your tools, you've been taught the basics. So how would you get this? Think of yourselves as detectives. All right, if I have a voltage across any element, especially a resistor, do I have the current through that element? Sure, I know that what? V is equal to I times R, period. Right? Remember, these two are in series. Are they not, class? Therefore, if I know the current through here, this has to be the current through that capacitor. Do you agree with me, everyone? Let me see your hands if you do. Agree? So what is that current? What is I2, class? Well, the voltage is here, right? So it would be 8 at an angle of 45 degrees divided by 2, or 4 at an angle of 45 degrees volts. Amps, right? Okay, I got I2, right? Now think about it. Once I have I2, what else can I get? This is a standard problem.
Yeah.
Can I get this? How?
Yes. Yeah.
There's this, right? Can't some of that I1 flow this way? You don't know I1, do you? What do you know though? Cut it right here. You agree that current I2 flows there? How many see that? Wouldn't that value of I2 times 2 minus J2 be the voltage here? How many see that? Forget the rest of the circuit. If I just had that capacitor and that resistor, this is 2, this is minus J2. I want the voltage plus the minus here, I'll call it V prime. And I know this current, I2. Isn't V prime just I2 times 2 minus J2? Take a look. Can you all see that? How many see that now? Sure, if that current's flowing through these two series impedances, there's a voltage from here to here, right? And that voltage would be that current times the impedance. How many see that? Can you all see it in the back there? Sure. So that means, and I'm going to do it this way. You want to throw it away for me? Thank you very much. Yes, miss?
Question, can we also use, current division to figure out I1?
All right. to use current division, we have to know if you have this I1, now I tell you, she's on to something, but if you had I1, you could use current division to find I2, right? Alright, what if you have I2? Now she's right about this. If you have I2, you can say, well, I1 times the opposite impedance plus these two would be the I2 I have. You can work it that way. You're absolutely right. I didn't want to do that one yet because it's a little more complicated. I wanted you to see that this is the voltage we could get first. Can you all see that? Show of hands, how many see we can get this voltage? You're absolutely right though. We can get V prime there. Can I call it V prime? So I'm going to say that V prime, but she's right. V prime would be equal to I2 times 2 minus J2. And I2 is that, so it's really 4 at an angle of 45 degrees. Now 2 minus J2 can be rendered, and I'm just going to show you one way. It can be, well, this is at a 45 degree angle. Do you agree? When you have 2 minus J2. Its magnitude would be 2 square root of 2, and the angle here would be minus 45 degrees. Do you agree with that? If you don't see that, start with just a little, in your mind, a graphical plot. Here's the real, here's the imaginary axis, and just put 2 minus J2, with 2 is here, minus J2 is here. This is the point. It is at 45 degrees, and if the two sides are 2 by 2 on that, it's a right triangle, the hypotenuse is square root of 2 times 2. How many see that right there? Guys, you all see it? So it's by the way, the angles are measured from this axis, the real axis, so this would be minus 45, all right? If it's positive, if it's going counterclockwise, the angles are considered positive, okay? And this is standard complex math. So what do you notice about these numbers? Just take a look. When I have 45 degrees here, and this is multiplication, and minus 45, what's the net value? 0, thank God. So here I have 4 times 2, or I have 8, right? At the square root, 8 times square root of 2, and this would be volts. How many see that? Right? I don't need to multiply it out, I'm just showing you. Correct, class? Now, that's this voltage right here, right? Please listen. I've got I2. So if I've got the voltage here plus the minus, don't I have the voltage here plus the minus, right? So don't I have this current? And I'm just going to call this I prime. And wouldn't I prime be just equal to that voltage that I call V prime, which is 8 square root of 2 divided by that impedance? Take a look at that. Do you all agree with me? If you have a voltage across J2, then you have the current through there, don't you? Do you all agree with that? You just take the voltage, that's the pressure, divided by the impedance, which happens to be J2. Now, that's in amps, but I want you to take a look at this. Do you see I have 8 divided by 2? That's 4, isn't it, class? So I'm going to say that's 4 square root of 2. How many know what 1 over j is? Well, it's minus j. Do y'all realize that? How many do? 1 over j is just minus j. If you do it in terms of angular measurements, if I had 1 over 1 at an angle of 90 degrees, in the numerator it would be 1 at minus 90 degrees, isn't it? Right? So this can be rendered, this 1 over j is just minus j. So I can say that's minus J here amps. And that's I prime. And that's the current that's flowing there. And what she said is absolutely right. I could have used current division. I didn't want to do it right there yet. But I want to say this. I1 would be equal to my I prime plus I2. Now that's Kirchhoff's current law. Whatever flows into a junction, right, flows into a node, flows out. I got this and I got this. So the sum of these two has to be supplied by I1, doesn't it, class? How many can see that? Can you all see it or not? Back there. You can? Okay, I'm just trying to make sure. You good on that, everybody up here? All right, now if you go ahead and do that, what do you get? I get that, which is I1 would be minus J4 square root of 2. And you'd have to add to it I2 plus, what is that, 4 at an angle of 45 degrees to get it. Now some of you are thinking, ugh, this doesn't look fun. Don't worry about this. Your calculators do this thing in a heartbeat when you get used to it. I'll just tell you what happens. This right here, you can leave it as just minus 4 square root of 2j. This, for an angle of 45 degrees, can be given as 4 here divided by square root of 2 times 1 plus j. I promise you. If you have something at an angle of 45 degrees, 1 at an angle of 45 degrees is 1 over the square root of 2 plus j 1 over the square root of 2. Promise you. I know this. Some of you know. Now you can add the real part, 4 over the square root of 2 here, and the imaginary part, which is going to be minus 4 square root of 2 plus 4 over the square root of 2 times j. And your calculators will do this, but that's I1. I don't, yes sir?
Is that the form that you wanted on the quiz?
No, I would want magnitude and angle. I would want magnitude and angle. You're going to probably think, are you going to ask for all this crap? No. I'll ask for certain things, but I'm not going to ask you to dissect the entirety of a circuit. You don't have enough time. I'm doing this just to show you how you could get any piece of information you want. All right? Now, once we get to that point, that I won. Now listen, what happened? You looked at the phone.
Oh, no, I was just, I got it, I figured out what I did. I was trying on my calculator to see.
Yes?
Would the negative J4 root 2 be, 4 root 2 to the negative 90 degrees?
Yeah, she's looking here. She sees a minus j times a constant, right? Minus j is 1 at an angle of minus 90 degrees. All right? And the way you always get this stuff, think of the complex plane. If this is the real axis, the horizontal, and this is the imaginary axis, or the j-axis, then if you've got, and remember, these are positive angles, and these would be negative angles, right? Would have a negative angular sense, because they're measured clockwise, all right, from the horizontal. So minus j is right here. This would be minus j, and it's the same thing as 1 at an angle of minus 90 degrees. Okay? It's getting familiar with the complex planes somewhat. It really is. Yep. So, now, so you're right. You could say that's really just 1 at an angle of minus 90. You're absolutely right. That minus j. Or this whole thing could be 4 square root of 2 at minus 90. Absolutely. Now, finally, I've got I1 here, right? Let's assume we can calculate. Y'all agree with that? Yeah.
I calculated I1 to be 4 at an angle of negative 45 degrees.
gonna have to just believe me.
I mean, I'm plugged in, negative 4.
Don't worry about it. We're gonna go with it. I'm not gonna spend time messing. Y'all with me on this? Let's say we get I1. Now, how do I get VS right here? Well, look, I know that VS has to be equal to the voltage here, right? Plus the voltage here, right? We go around this closed loop. It would be an increase of VS minus this voltage equals 0, correct, class? Or we could say that VS would be equal to this voltage plus that voltage, right? How many see that? So what is this voltage? Do we have I1? Yeah, assuming that's right. Do we have the resistance? Y'all see it or not? Isn't that, can you all read that 2 ohm there? So it would be 2 times I1. Or this voltage V2 here, since this is 2 ohms, would just be 4 at an angle of minus 45 times 2, or it would be 8 at an angle of minus 45 degrees volts, right? That would be from here to here. Correct, class? All right, now, wouldn't VS right here be equal to that voltage, right? Plus V prime. Y'all follow me? And I've worked backwards and sequentially got everything I didn't know. From here, I got the current flowing through there, so I got the current here, right? From the current here, I got this voltage because that current was multiplying these 2 impedances in series, and I could get that voltage. From this voltage, I got the current right there through J2, and once I had that current, I added that current in I2 to get this current, right? Once I had that current, I multiplied it by 2 to get this voltage, and I added this voltage to get VS. And that's it. It may bother you. There may seem to be, it's too complicated. It's not. If you think it through with just resistors, what I've just done, if you just put all resistors in and do the same problem, it's the same thing, only there's complex numbers now. That's it. There's real and imaginary parts to stuff. Yeah?
Once you solve for I2 to begin with, could you not just make 2 equations with the mesh loop analysis? And solve
Well,
for,
remember, we don't know this voltage, okay?
well, when you have 2 equations, 2 unknowns?
Well, I want you to, hold on. We had this current, right? I think I know where you're going. You're gonna say, if you have this current, why don't you just write an equation here and write an equation here, and then since you got I1, or I2, you could get I1. The problem with that, with mesh analysis, do you remember how it's the sum of the voltages around the closed loops is 0? And when you have mesh currents, you have to have the driver. We don't have VS. All right? We don't have VS. If we did, what you're saying would work. You're gonna have to trust me on this one. What I did, the way I dissected is the easiest way to do it. Now she's right back there. This current would lead to this current right here. It would lead to it for one reason, because we could use current division. We could say this current times this impedance over this impedance plus this impedance would be equal to I2, and we could invert everything and get this current. But once we got that current, we still don't have this voltage. To get this voltage, we'd have to get this voltage here no matter what. Okay? Now technically, if you had that current, you could get the voltage here, and you have the voltage here by just multiplying I2 times that. But the way I did it was meant to show you how to get each and everything going in a reverse order of the usual way. Okay? Now, the next thing I want to do is show you nodal analysis in the complex domain. We can do mesh too, but I prefer nodal right now. And I want to make sure that you appreciate one thing. You're going to have to get good with your calculators in this stuff, or you'll end up just not knowing how to solve things. And see, in this class, it's an engineering class, it's not a theoretical math class or anything like that, or theoretical physics. You have to have known answers with singular values. You can't have just equations. I forget to ask, are there any courses in any of your departments that talk about machine learning? There's stuff here in ours, in electrical and computer. Do you have machine learning classes in ME?
Yes.
You do? I would recommend that you, unless you have some reason not to jump into that. Machine learning, AI, artificial intelligence, has taken over everything. The designs I'm doing used to be done with genetic algorithms or they're global optimization algorithms. Now, computers are being more or less programmed to think, to come up with designs. And it's an amazing thing, so I'm going to encourage you to do that. Now, I'm going to do, let's see, 431. So this is with node. Thank you. All right. Let's see the question. Yeah, they just want V1 and V2. This is nodal analysis. So, have a look here. What's the first thing we do with nodal analysis? Usually. Yeah, if there's not a ground, you better put one in. There are no tricks for me here. Put it on the one common link that ties everything to ground, okay? Everything goes to that point, right? All elements of the circuit. Do y'all follow me on that? It's just the lowest, longest, in this case, lowest and longest piece of metal down there. Now, that's ground or it's 0 volts. Now you have to assign currents. I typically go from left to right, from top to bottom. Doesn't matter what you call these. I'm going to call that I1, okay? That's a current, so I don't need to label it. I'm going to call this I2. That's a current, I don't need to label it. And this is I3. Y'all follow me what I'm doing? As before. All right? Now we write current equations for this first node. Can y'all see it okay? For this node, whatever comes into, comes out, flows out. What flows in is 2 at an angle of 0 degrees, and I just put 2 because the 0 degrees doesn't do anything. It doesn't help it. Y'all follow me? Just put it as 2. And that's equal to the current leaving. I2 and I1. Or I1 plus I2. Everybody follow me on that? Show of hands here if you do. All right, now I have to replace the currents with the voltages, right? So what is I1 in terms of the unknown voltage? For the voltage node? Class? How many see it's V1 over 1? Right? Sure. So I1 is just V1 over 1. Why write a 1 down when you don't have to? Just V1 over 1 or V1. Do you agree with that? The units would be ohms. What's I2?
V1 over J2.
Say that again?
V1 minus V2.
Right. V1 minus V2 divided by?
J2.
Right. V1 minus V2 over J2 equal to. Okay, now the fun, this is the things that I wanted to get to before I leave. All right, that 1 over J business, I don't like fractions and I hate J's in the denominator. So what I'm gonna do is multiply everything by J2. Do y'all hear me on this? If I multiply everything by J2, this becomes 4J. This goes away. And this becomes J2V1. Do you agree with that? Now you collect coefficients. For V1, it's 1 plus J2 V1 plus, or actually minus V2 equals 4J. That's your first equation, box it. Let me just finish this. I know I'm over by a minute or so. What about the second equation over there? What is it, class? What flows in? I2. What flows out? 4, just put 4 down, plus I3, right? What is I2? Say it. Equals 4 plus, what is I3? Look, V2, say it again. Divided by minus J2. Now there's another class coming in, but here's what I would do. Multiply everything by J2. There's going to be a minus sign that appears in this one. It'll be a minus V2. And then organize it just the way I did over there and solve it. Now you're going to get a 2 by 2 matrix. You with me, class? Set it up and solve it. It's going to irritate some of you because you're not used to doing this on your calculators. Please help one another on your group me and stuff. State the type of calculator, and if you get links to how to do it, put it in there. I know they did this last time I taught it.